All right, guys. So for me, this starts where the fun starts in algebra. This really is kind of the concept that's going to carry us through the next month or two before our EOC. Obviously, we're going to branch off of it a little bit, but it's kind of the heart and soul of algebra. It's really what it's all about. Now, we're not going to go into all the details of it just yet. Just know that it's extremely important for us as we go forward. Okay. So we are looking at polynomials today. And what we're going to be looking at more specifically is factoring trinomials. Okay. So that's what we're going to learn today. We're at least going to get started with it. We're not going to learn everything about it one day. Obviously, we've got a month or two to do that. But let's just kind of review, right? So what we're looking for when you factor trinomials is binomial factors. All right. So factoring trinomials basically into binomial factors, right? So in review, okay, when we built these trinomials, all right, the review, we would have two binomials, and that could be something very simple like x plus 1 and x plus 2. Okay. And if we had those two, right, we put these together through the process of what is known as double distribution, right? Some teachers would call it foiling. Okay. I don't like to teach that because it only applies to binomial times binomial. It doesn't work past that. We look at it as a distribution process where we're just going to take each term and distribute it to the second. Okay. So we have x times x, which is x squared. We have x times 2, which is 2x. We have 1 times x, which is x, and then 1 times 2, which is 2. Okay. So what do we end up with, right? When we combine these two center terms, we have x squared plus 3x plus 2. Okay. So this is, right, binomial, whoops, into trinomial. Okay. And that is just taking factors, right, into products. Well, today, right, we're going to take these, right, trinomials, given trinomials, and try to factor them into separate binomials. Okay. Because, right, so as we look at, let's just grab a random one here. Okay. So that's our review, and going down here. All right, let's just start with x squared plus 9x plus 20. Okay, very simple one. Then we're going to work with this one. We're going to explain through this one, and then we'll do some more examples just to see if we can really catch on what's going on. Okay. So this is where the fun for me begins. Okay. Because these are just like math puzzles, right? We're given this, and we're basically asked to find the factors if there are any real factors. And that's just kind of highlighting on the next couple weeks worth of information, right? So sometimes these things don't work. But right, it's always fun to try and go through the process of trying to figure them out. So what we're looking for, what we're looking to do here, okay, is break this into two factors, right? This is what we want. Okay. We want two binomial factors. So something plus something or whatever. Okay. And we're going to multiply those together. Well, we do that by following along the process. Okay. So, right, we're gonna skip that for right now and understand that there is a standard form, and it's always going to be this, okay? It's always going to be ax squared plus bx plus c, okay? Where in this case, right, a would be represented by a 1, b is a 9, and c is a 20, okay? And this is just our standard generic form of it. And so there we have, right, this trinomial given to us where we have an a, b, and a c value for every trinomial, okay? So what we are looking for, right, to factor a trinomial, also known as a quadratic, which is what we're ultimately doing here, is factoring quadratics. To factor a trinomial, find two integers that multiply to get C, but add to get B. Okay. All right. So, right, we have to do this, right, to factor a trinomial, we want to find two numbers that when multiplied give me the C value, but when added give me the B value. And so this is where the fun begins for me, right? I'm in a numbers guy, so I teach math. So again, I'm just going to write down our problem again, right? So example 1 was x squared plus 9x plus 20. All right. And so we first have to start with the knowledge that, right, we are going to be eventually in our setup, okay, multiplying whatever number is here, right, in this position, by whatever number is here to get this, okay? So what are the numbers I could multiply together to get 20? Well, there's 1 and 20, okay? There is 2 and 10. 3 is not a factor. We could have 4 and 5, and that's it, right? Those are the factors of 20. So I'm looking at, right, that part right there, right? Multiplying to get C. These are all the different ways that I could multiply to get C. Now, I could have -1 and -20. That's also going to give me this +20, or -2 and -10, -4, -5. So in looking at, right, what are the things of 20, right, that multiply together? These are it, right? These are all the numbers we can multiply together to get 20. Now, obviously, there's fractions in there and things like that, but really we're focused right now on just the basics. Okay, so now I've answered that question, right? What two numbers? So we could have all of these different combinations, but what limits us on which ones we can actually use is that in the process of, right, putting these together and taking them apart, I must also create a pair that are going to combine and give me a B value, okay? So the B value here in my problem is 9, okay? So I'm looking at the factors and thinking 1 and 20. 1 and 20 could either give me it's going to give me a 21, right? This one's a 12, and this one, right, 9. So I know, right, we have a 4 and a 5. Okay, those are my numbers to go there. Now, the front term here is x squared. I know you get that by multiplying x times x. And so then, right, it's a +4 and a +5. And so there's our factors. That's how we're going to factor that trinomial, right? And if we FOIL this back together, if we go ahead and do the double distribution, you can see, right, we have x times x, which is x squared. We have x times 5, which is 5x. We have 4 times x, which is, right, 4x. And we have 4 times 5, which is +20. Okay, and so you can see, right? Here is the first stipulation. We multiply together to get positive 20. Second stipulation, right, is that these two terms are going to have to combine, right? Those two right there are going to have to combine to give me that 9. Okay. And so, right, voila, right? The fun has begun. Okay. If you figured it out when you FOIL it back together, or when you double distribute it, you're going to get what you had originally, right? So these are the factors. That's our answer, right? We know it's correct, right? Because 4 and 5 make 9 out of 20. Okay. So gonna look at some simpler answers here, or simpler problem. Just to let you kind of do one on your own to see if we've got it, and then we can move into some more advanced problems, and we'll talk about why they're advanced. So x squared plus 9x plus 18. Okay, so give you a minute there. And again, we know we want to try and break this into a binomial times a binomial. Now, looking at it, right, like we talked about yesterday, there's no GCF. So there's nothing to take out from every one of these that might make the problem a little easier. Okay, so then we have to look at, can we factor it? If we can't factor it, which there are times where it cannot be factored, that's when we call it prime. Okay, but we're not there right now. Okay, we're looking for real factors here. Okay, so think about it. See if you can work through this one. Right, what are the factors of 18 that give me 9? All right, so I know this, right? I know it's got to be x times x to give me that x squared in the beginning when I'm starting to combine them. But you think about 18, we have several factors, right? We have 1 and 18, we have 2 and 9, and we have 3 and 6. 4 doesn't go, or either does 5. And now we're back to this side of the factor. So we know we've got them all. Okay, which one of these are going to combine to give me a 9? Well, 1 and 18 combine and give me a 19. 2 and 9, that's 11. 3 and 6, lo and behold, there's my 9, right? Now, it does not matter which one you list where, because in putting them back together, right, we would have our answer. But that's the gist of it, right? Factors of 18 that give me 9, right? They multiply to get 18, they add to get 9. And that's the fun of it, right? Is that you're really challenging your knowledge of numbers. Okay. Now, I'm gonna throw a little curveball at us, right? I'm gonna get a little curveball in there. So that's just how easy it is when everything is positive. Okay. So here comes the curveball, right? So x plus 2x minus 8. Okay. So there's your problem, right? X squared plus 2x minus 8. All right, now the fun begins, right? Because, right, we're thinking about all the different terms. Okay, so again, setting it up, I know that's what I want to end up with, right? It's two binomials. Can it be done, right? Can it be done? All the ways I can multiply together to get 1 and or -8, rather. Okay. -8, that's important, right? I have to multiply together to get -8s. Well, how do you multiply to get a negative? I have to have one positive, one negative. And so we start to go down our list, right? So we have a +1 and a -8. That's going to do it for me. Or it could be the reverse of that, of -1 and a +8. That would work too. Okay. In which case, what do they combine for, right? This one would cause a -7. This one would cause a +7, right? Well, I don't need that, right? I don't need combined to make a +7. I need a +2. So you need to start breaking it apart, right? So if I have a +2 and a -4, that gives me -8. But the result is a -2 when combined, versus a -2 and a +4, right? Combined gets me the +2 I was looking for, right? All right, so that that's what I want, right? I want that positive 2 when we combine them. So again, because I know, well, that's not squared, right? I know I have x squared. That's what I've got to as my leading term in each factor, because I have to have x times x to give me x squared. And now I have to write in as -2 and +4. And it doesn't matter which one goes with which, right now. Okay, it will definitely in the future problems, but right now, right, it's just one has to be a -2, one has to be a +4, and then they combine to give me that +2x in the middle and -8. All right, so let's get a little fancy. Hmm, okay. So example 4, x squared. And they can be any variable really. It could be A, B, C. We don't care what the variable is as long as it's the same and we don't have any mismatched variables. So in looking at this one, right, no like terms, nothing to combine, nothing, no GCF here between those three. But can it be factored, right? Can we still break it into factors? Okay. So can I break it? Right. Give you a minute, pause the video, try to do this one on your own to see what you got. I'll give you this much, right? Definitely here. Right? Definitely have x times x. Okay, to start it out. All right, so thinking about 30, right? What are all the different ways that I can make 30? Well, I could go, and it's -30, so -1, 30. Well, that's going to be a +29, or -30 and +1, that's a -29. So I'm not even close to 7 yet. So what about 6 and 5? That's a very common one, right? 6 and 5, +6, -5, that's +1, and vice versa, -1. So not going to be there. Need to kind of branch out a little bit. 2 and 15, that's either 13 or 17, depending on how they're combined. That's not going to work. So 3 and 10, 3 and 10 make a nice 7. Okay, so decide on which one has to be negative versus positive. Okay, so 3 and 10, all right. If I need a +7, I'm going to need my 10 to be the larger term, and then I'm subtracting 3. And again, right, the more you do this, the easier it gets. Okay, some of us, it clicks right away, and we just get it, right? This makes sense. It's kind of fun to challenge yourself to find those factors, to put the puzzle together to make it work. Now, I'm going to teach you how to do this on the calculator. I'm going to show you how these answers appear on the calculator, how they present themselves, and all of that good stuff. But I'm a purist and really love to know how things are done by hand. So, be very aware that we're going to get lots and lots and lots of practice with this. So give you one more just for the fun of it, just to make things difficult for you. And then we'll call it a day for today and leave it where it's at. All right. Let's go with, all right, example 5. All right, so let's switch up our variable and let's go a squared minus 11x plus, oh, that would be 11a rather, just switching, see, it's so often I just use x. All right, so there you go, right? A squared minus 11a plus 24. Can you do it? Right? Can you do it? This is where we've got to expand our mind a little bit and understand what's going on. So I'll give you this much, right? If we could factor it, if it's possible, we know that's the start, right? That's how it's got to start if we can factor it. So what you got? See if you can get this one. Pause the video if you need to and try and work it out. Try and challenge yourself a little bit. And I'm going to work through it here. Now, I kind of ignore all of this and making my initial decision, right? So my initial decision is I just need to think about numbers that add to 24 or multiply to 24 rather. So the 1, 24, 2, 12, 3, 8, 4, 6, and that's it, right? So I've got all those combinations, right? 1, 24, 2, 12, 3, 8, 4, 6. All right. Now, that's all well and good, right? All of those are going to multiply together to give me 24. The question then becomes, what combination of those gives me a negative 11? Well, 1 plus 24 is 25, 2 plus 12 is 14, 3 plus 8 is 11, but that's a positive 11, okay? And so I got to kind of challenge myself to remember how integers work, right? If I multiply positive 3 times positive 8, that is positive 24, okay? But there's also another way to get positive 24, and that would be to consider, right, a negative, right? So there's kind of this pattern that forms, but I don't want to go there yet until we've had quite a bit of practice, but they're both negative there. So it's a -3 and a -8. That's how those are going to come together, right? Once I've honed in on 3 and 8, giving me that 11, then I can kind of figure out how do I make it a -11, right? Or is there some combination here that would give me a different value? But it's about as complex as it gets, guys. So, in looking at these, just have some fun with it. Going to put some assessment out there, a couple of questions for you just to answer and see if, right, we can hone in on a set of binomial factors for different trinomial expressions. And if you have any questions, problems, concerns, guys, just let me know. But like I said, this is kind of where the fun begins. So definitely going to want to get a hold of this concept. Going to want to get a lot of practice with it. Going to want to take some good notes and ask questions. If you have even the smallest question, we want to get that clarified as fast as we can. Hopefully today's lesson, though, went pretty smooth for you, made a lot of sense. And if not, please reach out to me so we can get that fixed ASAP. Thanks, guys.